Alright, hey everyone, this is Andrew again with the continuation from the last video. This is the off-season robot project for Stronghold. I think this is video 3, maybe it's 4. I've actually lost count entirely. Anyways, to continue off back from where we did last video, I completely forgot last video. I mentioned about how I didn't make space for my wheels. So I added them in the model and then I didn't change the dimensions. So that was dumb of me. That's something I need to change. So the dimension I want to change is this 8 inches here. So my initial thought was I'll make that 8 inches for bumper rules. And I forgot I'm not mounting my bumpers directly to the lower half of my frame that the drivetrain's on. That's going to be in an upper size. So it's good that I understand my full dimensions, but I'm going to say I need to change this drastically. So I'm just going to keep in mind that this number needs to be 26 or below, and that's my total width. So, okay, seems like this shouldn't be that bad. Okay, so that seems reasonable. 5.5 inches. It's going to change this tube size to be 3.5. But that's still plenty of room for me to work with, so I like that. And that's going to get my frame to be within a legal configuration. It's nice to be the right size. And just so I can remember for myself. Oops, I need to put my phone on airplane mode because I'm recording using my phone because I don't have an actual microphone. The people are starting to send me messages. So I'm just going to put this out here to have my width be around 26 inches and my length be whatever this is. It's 33.5. And I'll add some distance dimension just to get this nice and pretty. I don't really care what it is. Cool. Alright. And then I like using driven dimensions just so I get a reference point so I can look at something and understand what I'm looking at. So 33.5 and 26. Actually, it's a super easy thing I could do. I don't know why I don't do this before, I just saw this now. So use a path length dimension to figure out what my frame perimeter is. So 119 inches within legal limit. That works for me. Okay. So I got this out of the way. So the nice thing I can do is I can now go to this model, and I was talking last video about this horizontal roller I want to probably end up being a belt. And now I can go to a little bit more over the top detail, because if these rollers are going to be horizontal, there's going to be a top view of them as well. And I'm going to model these as slots. I'm thinking about going with belts, because I remember 2012 971 robot. Love that robot. Its name's Renegade. Had one of the best ball hopper solutions that I'd seen. It had a really amazing way of taking in a lot of balls and taking in multiple at once and organizing them into single file line with minimal jams. They had to get a lot of work in to get it, and balls kept falling out, and granted, it was way overcomplicated for the game and completely unnecessary, but I love it nonetheless. Because it uses belts, and it's proof to me that belts are going to work to move these boulders, and that's all I need. I like building upon assumptions that I can make, that I know I can make because other teams have already made them, if that makes sense. So if you can do something that you know works because someone's already made it work, that is fantastic. And the reason that I say it's fantastic is because if you're doing off-season stuff like this, like it's just a design project for fun, you want to be able to do all the testing, of course, but it takes time and it takes effort to do all that prototyping. And me, I'm sitting here in my room making these videos, so I don't have time to go out, get some boulders, get some GT2 belts, and pretend like I know what I'm doing. So if I can think back to previous robots and I know my history on what's worked, it gets me a good idea of what I can make assumptions on. So this is going to be my belt path, my theoretical belt path. And I'm dimensioning the outer wall, or the inside wall of the belt to the center line. And actually I'm going to show what I did just once more, because I didn't know about this before until I think Travis showed me. So if I dimension to the center line, this is going to show me the distance between the belt and the center. And that's fine, but the ball's going to be taking up both sides of the center. So this is essentially a radius of the ball. What I want to do is I want to figure out how much compression I want to put on it. And I'm thinking about an inch. Solid inch compression should work. Maybe it's a bit much. Maybe I'll do like 3/4 of an inch. Yeah, 3/4 will work. So if I want to do 3/4 of an inch, I want the distance between my two belts to be just about 7 1/4 inches. So I can do that, and I could make this dimension, for example, let's say 7.25/2, or just so I can not have to look at that and reference the math in my head, I could just move over to the side, and it doubles over the center line. So that's pretty useful. So I can have that be 7 1/4. Whoops. And of course, it's going to increase the diameter. That's fine. It's fine for right now. As for this, so this is going to be some kind of a belt. I don't know if it's going to be a timing belt. I don't know if it's going to be polycord. But I want to reference this as a clean number, as a clean number relative to this edge. Now, the reason I'm making this a clean number relative to this edge, the center at least, is because I want to do it. There's no particular benefit. There's no reason. There's no rhyme. Actually, I want on the other side. But yeah, a lot of this stuff is, well, I'm doing it because I feel like it. It makes sense to me. May actually extend this out pretty far. That's an interesting thought I've never considered. What I will do is I will put the start of this on the midway radius of my roller. So that's going to be 1.5 inches. So I'll make this 0.75. So I'm not exactly dimensioning the entirety of it, but I'm dimensioning the dimensions that are important to me. And there's no reason I made this exactly at where like it starts at the middle of that roller. Does not matter. I chose it for arbitrary reasons. I have this small, minute thought in my head that maybe it'll be more beneficial to get this horizontal control of the ball early on. I could be completely wrong, but like I said, a lot of this is just testing out ideas. So until then, totally gonna try it out. As for the radius, this is gonna be up above the tubing, so I'm not limited there, but there's no reason it needs to be pretty large. So I'd say 1.5 inches is a pretty common roller size. So if I want like a belt thing, or not belt, if I want a pulley size, 1.5 inches is a pretty common, or whatever that is in metric. Just because it's pretty strong. You get nice not nice control, but you get nice tension over whatever you're doing, because whatever the larger of whatever you're working with, I think I don't know the science behind this, so don't take everything I say like as law. I remember reading before that teams like 11-14 use larger sprockets because it's easier to tension, or they hold tension better, and that's kind of what I want here. I've seen 1.5 inches used for rollers or for intakes used pretty well, so I'm going to go with that. Oh, I don't want the radius to be 1.5. I want the radius to be 3/4. Cool. And that's how it's going to work for me. So this looks pretty well dimensioned, and I can change this at any time. It's the nice thing about it. I'm just in a sketch right now. I haven't made a single part. I haven't done anything outside of making a sketch. changing sketches is pretty easy. And it's looking like this is going to turn out to be a pretty fun robot to make. Pretty simple so far. What I'm not liking that I have a super long run of this, super long belt or polycord run. I may change that into multiples, just to make sure that it all works nice. But I'll see in a bit. Who knows? I may just put maybe another pulley or like a round pulley right here. And this is I'm going to use these lines as the center of whatever my belt or my pulley or my tube, my plastic tubing is. I'm not going to dimension the outer diameter and find out exactly what it is or the outside pitch length because it's really not necessary. It's such a small distance that it doesn't matter. I have my 3/4 inch compression. That's going to be fine. Cool. So that's there. And actually I can do that. That'll work out nicely. That of course doesn't include the radius, I don't think, but it's fine. That's just a model, just to show where I have control over the ball. Actually, ooh, so that's another thing I just forgot about. If I'm controlling the ball over center, then I'm not compressing an effective 8-inch radius, I'm compressing a smaller radius. So what I need to see is what is this distance from, I'm just going to go off the center from there to there. So I'm going to say all 3 of these points are horizontal to each other. Oops. Yeah, what is this line? I'm going to use the center line. I'm going to click on it. So it's like 7.6 inches, really. So make that, maybe 7.6. Just make it a really clean number because I like clean numbers. Instead of taking away doing a 3/4 inch of compression, I'm going to do 0.6. So that way, I can have a 7-inch. And that way, because I have inch and a half diameter rollers, or whatever the 3/4 inch radius, these center points are going to be pretty clean numbers. That actually lines up perfectly there. Cool. So that works. I have an idea. I'll get to it later. So that's going to be handled pretty well. Okay, now fun intake stuff. Actually, no, I'm going to take care of that now. So my initial thought is, why shouldn't I do something like this? Yeah. Because the outside of my frame, realistically, is going to be like right here. Yeah. So that's still within my frame perimeter, and granted, it's flat, so it's hard to see, but this is actually going to be above my 2x1 frame. So really, I could have this as far as here as I want, and the advantage I'm seeing of doing that is when I get my ball inside of my frame perimeter, it gets grabbed immediately, and then it gets pulled in. So if the ball's going up, it gets pushed up, as soon as it gets to around this point, it's being pulled in. And that's not even at max height yet. So I like that. I think that's a really usable idea. Yeah, I think I'm gonna do that. And I think I'm gonna follow my initial instinct. I'm gonna turn this top whatever into a piece of framing. So I'm gonna have a framing at the very top. I'm gonna use that top to have a polycarb guard, really thin one. That's gonna go around there. I'll probably do 1/2x1 tubing. 1323 used that, or 971 used that on the Offseason bot in 2015, and then 1323 used either 1/2x1 or 1x1.5. I forget which. We used some weird size tubing. I like using the not new but non 1x1 or 2x1 or 2x2 size tubing. It has some interesting niche uses, so I like playing around with that. All right, so I think I understand how this robot's going to work now, for the most part. There's still a lot that needs to go on, but yeah. Simple intake that can just come out, do its thing. I like it. I want my intake to be the width of the robot too. Now as for this, I actually gotta do this now. What height do I want my intake at? How far out do I want it? I'm probably gonna want that point relatively close. And then I may have actually a second set of rollers. Heck, you know what? I want to see what happens if I have 2 sets of mechanisms right next to each other. Just to see what happens. I'm curious. It's heavy, it's unnecessary, but this isn't going to be built, and I think it could be a good idea. Why not? And realistically, this robot doesn't have weight problems. It's an intake. Maybe I'll do a video later on at a climber on, but realistically, this is going to have 0 issues with weight if we design it smart, which we will. I will include a lot of lightning, or what I think is intelligent lightning on this. There's a way to lighten wrong. There's many ways to lighten wrong. I'm hoping I can show that there's better ways to do that. I'm hoping at least my way works. It's worked so far. I do not know if it's completely good or not. So I think adding a second wheel will be nice, because my initial thing I didn't like about having the one wheel so close, even though it worked pretty well. Oops. Yeah, it worked pretty well, but what I didn't like was it limited my intake range to just right there in front of my bumper. I would have to drive right up to the ball and not bump it away, which a skilled driver can do. But I always like to design for drivers who are not skilled, because hey, it's useful sometimes. Sometimes your drivers are not Takumi from 1678. I mean, I wish, but unfortunately it doesn't always work that way. Okay. So I'm thinking something like this. Have one that's super close to the bumper. Oh, and that could work, because the second row could actually be inside if I wanted it to be. It could be inside the bumper, theoretically. Yeah, as long as the second and that inner row just won't be as wide as the bumper. It'll just be as wide as the opening. Huh. I like it. Yeah, this could turn out pretty nicely. Alright, now to do the fun part. Or actually, that's not how I want to. I want to model a line that goes between the outside of my wheel and the outside of my roller. And what I want to do with that is I want to make sure, number one, it goes through the center of each. I don't want it to be tangent. Just want it to be coincident. Okay, cool, you can go ahead and move that. I want to be coincident with the centers. And what that accomplishes, oh, whoops-a-daisy. Oh. That accomplishes is it lets me position my ball and see how much compression there is on it. Okay. Alright, this seems to be moving. Why is that limited to there? That's coincident in two places. Okay, cool. That's not supposed to be coincident there. Nice. Okay. So I want to see if my ball is going to be right in the center, which if I did my geometry right, it should be. Make that equal. How much compression do I have on either side? And since I cannot tell which is which, I'm going to delete one of these. Which one is this? That is the necessary one. Cool. Did deleting that do anything? Somehow, yes. Not sure what though. Oh, okay, cool. It would just reference that. Nice, okay. So this is giving me my ball at maximum compression within my intake. My goal is to make sure that this isn't too much. And the way I can figure that out is I want to see what this is. So that's compressing it by 3/4 of an inch. So, or yeah, like 0.8. So the max can be 1.6 inches of compression at that point. Can I lessen that any? So I want to keep contact at this point, but at the same time, oh no, made it worse. Okay, cool. So I want to move it out. But then there's also compression here to be considered. And the way I'm going to model this, and this is going to be while it's still on the ground, is I'll go from the center to the center of this one. Cool. And that's going to be, okay, that's going to be 1/2 inch compression. That's not bad. So going 0.7, moving this out just a bit. Huh. But yeah, I want ideally like 1/2 inch compression, really. Oh, I'm dumb. What I should be doing is I should be modeling how much compression I have when the ball is directly beneath it. Also, why is that vertical? Or horizontal to that? It should not be. I'm gonna delete that reference. Nope, that was not it. There, cool. Alright. Alright, now I'm going to make that vertical. So understandably, I'm going to have the most amount of compression at this point when it's vertical. And that's not how I want to model this. I want to model it like that. Have a separate line there. And then I just want to make sure that these points are vertical there. Cool. Alright. So what's this? That's my maximum at 3/4 inch compression. I wonder if that'd be interesting. Is there a point where I can make all three of these equal? Granted, I don't know if that's a good idea. I think it'd be cool to try. I don't know, see what the results are. I always like just seeing how geometry works out. Okay, so that seems to be wanting that only. Can I? No? I don't get what's going on here. That's my ball, it should be. And that is... No, is it? I honestly cannot tell. I'm going to backspace a little. Cool. And this ball is not a constant diameter. And I do not want that. There. Much nicer. And I just did something. What did I do? Okay. So that ball, make that 8 inches completely. I want this to be the midpoint of that, which makes this, why is that no longer equal? Why? Okay, well it's not going to get bigger in size. What do? I locked the initial roller dimension by doing what? What have I done to lock this? I made some kind of relation error. Alright, this video is getting close to half an hour long, my bad. I'm going to close this up and just start the next one. Alright, thank you very much for watching. See you next time.